Right, this is an exam question asking us to use the data that they've provided to calculate the standard enthalpy of solution of magnesium chloride. So it's given the enthalpy of lattice dissociation and it's given the two enthalpy of hydrations. So I've underlined dissociation because sometimes they give you the enthalpy of lattice dissociation, sometimes they give you the lattice enthalpy of formation. So we need to be careful about which one we're doing. So to answer this question, we need to draw a Hesse cycle. So if we start from magnesium chloride, which is our ionic solid, what we're doing is we're dissolving that in water to give Mg2 plus, which is aqueous, and 2 Cl minuses, which are also aqueous. And that's our enthalpy of solution, which is what we're trying to work out. That's our enthalpy solution, or X, because that's what we're trying to work out. So it gives us our lattice enthalpy of dissociation, which is magnesium chloride as an ionic solid going to Mg2 plus, gaseous, and 2 Cl minus, which is the gaseous, because remember the lattice enthalpy of dissociation is taking 1 mole of our ionic solid and turning it into its gaseous ions. So this is the lattice enthalpy of dissociation. So instead of writing the whole thing out, I'm just going to write the figure, which is here. So that's plus 2493. And then I need to write the enthalpy of hydrations on, and that's separate for each ion. So the magnesium 2 plus hydration enthalpy is minus 1920. And the chloride, there's 2 of those, so I need to times that figure by 2. So that's 2 times minus 364. Right, so now I just need to use Hess's law. So I'm going from the magnesium chloride as a solid to the magnesium aqueous ions. So going from there to there is the same as going from there down to the gaseous ions and then back up to the aqueous ions. So X, which is our enthalpy of solution, we're trying to find. So if we go in the same direction as the arrow, we're adding it. So that's plus 2493. And then we're adding these 2 arrows as well. We're going in the same direction as them. And we've got to remember to add 2 of our chloride ions because we've got 2 Cl minus. And on this diagram here, I've not put the kilojoules per mole in because it makes the diagram uncluttered. But when we write our final answer, we must remember to put that in. So if I stick those figures into a calculator, I will end up with minus 155 kilojoules per mole. And that's my final answer. So if you look, this is 2 marks. So it's 1 mark for all that working out, which seems a bit harsh, but that's what they tend to give you. And then 1 mark for my final answer.